like we are saying, principal focus, I said this is a point called principal focus from a converging lens. So you can see that these are three parallel rays. So when they pass through this lens, they meet at this point. A point at which parallel rays meet after passing through a converging lens is called principal focus. Then, if it is a concave lens, where is principal focus on the concave lens? The beginning of the rays, because I told you in concave lens, all of them are coming from this point before they go on their separate ways. So their starting point, where they all started from before going on their separate ways, is called principal focus of a concave. So how do we define? We say principal focus is the point at which the ray of light is the point from which the ray of light diverge after passing through a what? Concave. Is the point from which they go on their separate ways after passing through what? Concave. Here is the point at which they come to a point after passing through. So that's another principal focus. Now, distance between this principal focus and this optical center, this and this line, from the optical center to the principal focus, that distance is called. So this principal focus is denoted with capital letter F. Now, distance between the principal focus and that optical center is called focal length. Focal length, and is denoted with small letter f. So when you see capital letter F in lenses, it represents principal focus. When you see small letter f in lenses, it represents focal length. Principal focus is where they meet. Focal length is the distance between where they meet and the optical what? Center. So how do we define? Focal length is the distance between the optical center and the what? Principal focus. So I can touch it now. This line from here to here is called focal length. This point exactly is called principal focus. This point exactly is called optical center. This line that joins the optical center to radius of curvature is called principal axis. While here is called radius of what? Curvature, because it is the radius from which the sphere fall apart. So the last term I'll be treating is power of lens. Power of lens. Power of lens. Power of lens is the reciprocal of focal length. That is P is equals to 1 over what? F. So the power of lens is the reciprocal, 1 over, that's reciprocal. Reciprocal of what? Of focal length. Meaning, if you want to get the power of length, you have to say 1 over focal length, that's a small f. So I am done with important terms of what? Lenses. Now let us go to image formation by lenses. How does image form? This is an example of lens. How does the image of the object I'm looking at form on this lens? And this one is a concave. This one is a concave because this one is thicker at the edge than at the what? Center. So this one I'm using is concave. And that concave is the one used by somebody who is suffering from a short-sightedness. He can only see close, he cannot see far. People like that use a concave. So how does image form from a concave lens? And people who are using this one too, there are people who can see far but cannot see close. They use what? Convex. How does it? They can see far. They can see as far back as that point, but they cannot see an object close. So when you see them taking textbook, you see them moving that textbook backward like this before they be able to read. Those people are suffering from a long-sightedness. So they use this. It means they can see far, they cannot see close. This one can see close, they cannot see what? Far. Now, whether we are using convex or we are using what? Concave, how does the image form on the concave? Now, in case of convex, these people that can see far but cannot see close. In case of convex, the image formation is determined by the position of the what? Objects. When you are using this type of lens, convex, where is the image of the object you are looking through the lens is going to be formed is determined by the position of the what? Object. So these are the analysis of it. The first one here says when the object is at infinity, we cannot see anything here. It shows that the object is very far. Now, this is a lens. So the image of the object is going to be formed on the what? On F. And I think I've told you that principal what? Focus. Principal, if I determine here as but if I'm talking about from here to here, I will call it what? Focal what? Length. So we can see F here. So when the object is located as infinity, a very far place, we expect the image to be formed on the what? Principal focus. So that is F. And the characteristic of such an object is going to be real. It's going to be inverted. It's going to be what? Diminished. So let's explain the three objects. Which object is real? Object that can be cut. Object that can be what? Cut on the screen. Because there are two types of objects. I have real, I have virtual. Real object are the object that can be cut. Past tense of catch on the screen. Virtual are images formed by mirror. You cannot catch yourself through the mirror even when you see your image. Because your image in the mirror is what? Virtual. But any image given by lens must be real. It must be an image we can later touch. And that's why in our camera what we have there is lens, mirror. Because we need an image that can be cut, past tense of catch, when the photograph is what? As what? Taken. So any image you can catch like this is what? Real. So any image given by these lenses, they must be what? Real. And they must be what? Inverted. Inversion means they must be in the opposite direction to the object. For instance, in your mirror, when you point your left hand to the mirror will give you what? Right hand. That is exactly what is called what? Inversion. So you can see, if the object moves upward, the image must move what? Downward. That's the meaning of what? Inverted. Then the last one is it must be what? Diminished. Meaning the object must be smaller than the what? Image. So the image is at infinity, the object is at the principal focus, and the characteristic of such an object is that it must be real, an object we can catch, it must be what? Inverted, an object that moves in the opposite direction. Sorry, image. The image must be real, the image must be what? Inverted, meaning moving in an opposite direction to the what? Object, and it must be what? Diminished. The image must be smaller than the object. So the first position of an object by convex is when the object is at infinity. Now, second position, when the object comes beyond, small beyond 2f. The meaning of 2f, if this is principal focus, or I call it focal length, double of it becomes 2f. That is, here to here is f, here to here is another f. So from here to here now become what? 2f. That's how you got that. So 2f does not really mean double of the focal length. Double of the focal length. If from here to here is a focal length, then here to here is another focal length, then from here to here become double of what? Focal length. Now, when the object, this is object O, is beyond the double of focal length, meaning here we did not see the object at all, but here the object is coming nearer now. The object has been seen, but at the end, at the back of the double of what? Focal length. So we expect the image, this image. The image will move from F to, if this is F and this is double of F, like I've done here. This is focal length, and here to here is another focal length. So from here to here become double of what? Focal length. So when the object moves beyond, that is what you say. When the object moves beyond 2f, meaning when the object is skewing at the back of 2f, then the image is expected to come in between f and 2f. You can see that the image is at f here. Now the image has been pushed. As the object is being pushed forward, image 2 is being pushed forward.